All right, well, let's imagine a theoretical population. And I've drawn a population of little human beings on the board here. And so this is going to define our population here, all of these individuals. And in fact, we can formally define a population as a group of individuals of the same species. And when we're talking about population genetics, we talk about the gene pool. And the gene pool is the sum total of all the alleles in the breeding members of the population at a given time. And so let's look at this population and define some properties of this population. So the first property we can define is that there are n individuals, and in this case, n equals 16. There are 16 total individuals here. And what we're interested in here is locus A. And so we can talk about the number of alleles there are in the population for locus A. And of course, if you look here, you can see that there is big A and little a, and the total number of alleles is 2n equals 32 alleles in our population of 16 individuals. And of course, that's because we have a diploid population here. And so the question we'd like to ask, the first question we can ask is, what is the frequency of the different genotypes here? So remember that the genotype is defined by the two alleles. And so we can quantify those genotypes just by summing them. And so let's do that over here. So let's talk about how many of the big A genotype we have in the population. We just need to go through and count. There's 1, 2, 3, 4, and I see only, there's a fifth right there. And so we have 5 big A genotypes in the population. Let's do that for our other genotypes as well. So for the heterozygote, big A, little a, we have 8 of those. And for the homozygote, little a, we have 3 of those. And of course, now what we'd like to do is quantify the frequencies of those genotypes. So we just divide by the total number of genotypes in the population, which is the number of individuals. And so this is going to be 5 divided by 16, which is equal to 0.31. This is going to be 8 divided by 16, which is equal to 0.5. And 3 divided by 16 is equal to 0.19. And of course, if we add up the frequencies of those genotypes, they should sum to 1. And indeed, they do.